Hi, everyone. Today we're talking about rank correlation. Have you ever wondered how we measure the relationship between rankings, like how your favorite fruits and your friend's favorite fruits might match? Let's dive in. Correlation measures how well the relationship between two sets of things can be described with a straight line. Here, both variables can be measured. If the variables are qualitative, we can assign ranks based on their qualities. In such cases, rank correlation is used to find their relationship. The correlation coefficient computed using such ranks of two qualitative variables is known as the rank correlation coefficient. Wait, what are qualitative variables? Qualitative variables are things we can describe with words instead of numbers. They tell us about the categories or types something belongs to. For example, favorite color, red, blue, green. Type of pet, dog, cat, fish. Weather, sunny, cloudy, rainy. These don't have numbers, but they still give us useful information. Why use rank correlation? For example, you and your best friend both love ranking your favorite fruits. You decide to rank them from 1 to 5, your least favorite. Here's what you both think. Now, rank correlation is like checking how much your fruit rankings match your friends' rankings. If you both rank them the same way, the correlation would be very high, close to 1. If your rankings were totally opposite, the correlation would be very low, close to -1. If your rankings are just random compared to each other, there is no correlation. Rank correlation helps us see if your rankings align or differ. Spearman's rank correlation coefficient. The most common method for rank correlation is Spearman's rank correlation coefficient, defined as RS minus N is the number of observations. D is the difference between the ranks of two variables. Example. First, we calculate the difference D between their ranks. Then, square these differences and find their sum. Referring to our example, let's calculate D. 1 minus 2 equals -1, 2 minus 1 equals 1, 3 minus 3 equals 0, 4 minus 5 equals -1, 5 minus 4 equals 1. Square these differences and find their sum. We get D squared equals 4. If we put everything in, we get a correlation coefficient of 0.8. This means the rankings have a highly positive correlation. That means you and your friend's favorites are very similar. Sometimes, data with quantitative variables, like height or weight, is analyzed using rank correlation. This is done by assigning ranks to the numbers based on their size. Let's do one example. Teachers collected data from a sample of 8 students to study the relationship between students' abilities in statistics and accountancy. To calculate Spearman's rank correlation coefficient, we first assign ranks to each student for their statistics marks and accountancy marks. 98 is the highest value, so it gets rank 1. 90 is the second highest value, so it gets rank 2. 82 is the third highest value, so it gets rank 3, and so on. Similarly, ranks are assigned for accountancy scores. Let's calculate D, the difference between ranks, and D2, squared differences. If we put everything into the formula, we get a rank correlation coefficient of 0.86. This means the rankings have a highly positive correlation. Tied or repeated ranks. Sometimes, 2 or more individuals have the same rank in one or both characteristics. This is called a tie. In such cases, the average of the corresponding ranks is assigned to each tied observation. The next observation is then given the rank that follows the highest rank used in the average. When ranks are repeated, a correction factor, frac m(m²(1), is added to sum D2, where m is the number of times a rank is repeated. The formula for Spearman's rank correlation coefficient with ties is. Let's calculate the example. First, let's assign ranks to statistics. 50 is the highest value, so gets rank 1. 45 is the second highest value, so gets rank 2. 40 is the third highest value, so gets rank 3. 30 is the next highest value and is repeated 2 times. The average of corresponding ranks, that is 4 and 5, which is 4 plus 5, 2 equals 4.5. 4.5 is assigned to each observation. The next highest value is 20. Since ranks 4 and 5 are already used, we will assign rank 6. The next highest value is 10 and gets rank 7. Now let's assign ranks to accountancy. 40 is the highest value and is repeated 3 times. The average of corresponding ranks, that is 1, 2, and 3, which is 1 plus 2, 3, or 3 equals 2. So 2 is assigned to each observation. The next highest value is 30. Since ranks 1, 2, and 3 are already used, we will assign rank 4. Similarly, ranks 5, 6, and 7 are assigned. Let's calculate d and d squared. Sum d squared equals 2.5 and n equals 7. Here, rank 4.5 is repeated 2 times in rank of R1, and rank 2 is repeated 3 times in rank of R2. So the correction factor is frac 2, 2, 2 minus 12 plus frac 3, 3, 2 minus 1, 12. If we put everything in, we get a rank correlation coefficient of 0.91. Thank you for watching. If you found this video helpful, feel free to like, subscribe, and share it with others who might benefit. Thanks again, and we'll see you in the next video.